Hello, and welcome to the third installment of the State of Science. We're so delighted that you're able to join us here tonight. My name is Lynn Miranda. I'm a professor of applied and computational mathematics and statistics and the Charles and Jill Fisher Provost here at the University of Notre Dame. We're so delighted that you've chosen to spend your evening with us. Before we get started, just a couple of logistical notes. On the same page where you are streaming this video, there is a button above the video stream where if you want to submit a question that you would like to ask of any of our panelists, you can do that. We'll try to get to as many of your questions as possible. We would love for this to be an interactive session. So get ready to jump right in with us. I'll start by introducing Holden Thorp, who is, I'm very happy and proud to call him both a friend and colleague. He's been with us on several of these State of Science conversations so far. Holden serves as the editor-in-chief of the Science family of journals. By the Science family of journals, we're referring to the Science flagship, as well as Science Translational Medicine, Science Signaling, Science Robotics, Science Immunology, and the open access journal Science Advances. So he serves as editor-in-chief for that whole family of journals. In addition, he is currently on leave as a professor of both chemistry and a chaired professor of both chemistry and medicine at Washington University in St. Louis. He also previously served as WashU's Provost, as well as the Chancellor at the University of North Carolina. Holden and I have a little thing going between, since I worked at Duke for a long time, a little thing, that little Tar Heel Duke thing going. But today,
how was the game this weekend?
Tar Heels. Yeah, I know. We don't care about the Tar Heels or the Blue Devils. What we care about is that it's St. Patrick's Month, which is a big deal for us here at Notre Dame. I see Holden is wearing his Notre Dame green St. Patrick's Month pullover, so we're really pleased and proud of him for coming over to the Irish way. Holden, welcome back, and thank you so much for joining us again.
Great to be here. Go Irish.
There we go. Next, I want to introduce Jake Yeston. Holden, since today we're going to talk about how to place your research in top journals, Holden decided to bring along one of his colleagues from Science magazine. Jake serves as the editor for physical sciences research at Science, so will be a nice complement to the people who we have on the call. Jake holds a PhD in chemistry from Cal Berkeley. So Holden and Jake are both chemists, but I think they have a nice broad view of science. That's certainly been my experience with them. And he conducted his postdoctoral research at the Max Planck Institute for Quantum Optics before eventually joining Science magazine in 2004. An interesting little factoid about Jake, sticking with the St. Patrick's Day theme, is that Jake can sing "Oh Danny Boy" in Yiddish. I'm sure we will call on him to do that at some point or another during this broadcast. So Jake, thanks so much for joining us this evening.
My pleasure.
Last, I want to introduce Jessica Payne. One of the things I've loved about this series is that we have the opportunity to bring in some of our wonderful faculty from Notre Dame. And today, last week, it was Shuman Datta from the College of Engineering. This week, it's Jessica Payne, who's in the psychology department in our College of Arts and Letters. She's an associate professor of psychology, and she is the director of the Sleep, Stress, and Memory Lab here at the university. Jessica was recently selected by the National Academy of Sciences as the 2021 Seymour Benzer Sidney Brenner Lecturer. We're really proud of her for that. Congratulations, Jess.
Thank you.
And she's currently leading a multi-year study on memory and sleep in middle-aged adults, and it's supported by the National Science Foundation. Jess has been a member of the Notre Dame faculty since 2009, coming here after completing a postdoc at Harvard Medical School and Harvard University. So Jess, we're so pleased to have you with us here tonight as well.
Yeah, thank you so much, Marilyn. I want you to know how much I appreciate having this this privilege. And Holden and Jake, I can't stop thinking that it would have been so much better to have this conversation for me personally 5 or 10 years ago. So I know that a lot of my students are watching this. So students, early career researchers, definitely keep your ears open. I think you're just about to hear some things that I wish I'd known a lot earlier.
So we're really hoping that we get into the nitty gritty about how to place your research in top science journals. I'm going to turn things over now to Jess and Holden and Jake, but I'll see you at the end of the hour. So Jess, take it away.
Okay, sounds great. So why don't we do that then? Why don't we just jump right in, and I'll ask the question that probably so many of us are waiting on, which is, how do you get published in science? No, I mean, if it's okay, I'd like to start with those types of detailed questions and then maybe move to the more abstract and philosophical as we go. But in terms of that question, what are the tricks of the trade, if you will, if there are any, for trying to get your work published in top scientific journals like Science?
Well, I think maybe we should start with Jake, since, but just so everybody understands what our roles are, Jake is in charge of all of the physical sciences for us at Science. So he handles papers himself, and he has a team of folks that work with him who cover everything from biochemistry on one end to astrophysics and quantum computing on the other, and everything you can think of in the physical sciences that are between those. And Science, unlike many academic journals, has professional editors whose full-time job is handling papers. One of our journals, Science Advances, uses academic editors, but for Science and for the other subscription journals, we mostly use professional editors like Jake, who work with a team of folks that handles their papers. And I only get involved either if there's a problem or if it's so exciting that we're making sure that the PBS NewsHour wants to cover the paper. So I'll hand a lot of these questions about the details of this over to Jake, and kind of just chime in a little bit about what we see at our other journals and maybe some of my experiences as an administrator or as a faculty member.
That would be great. So Jake?
Yeah, sure. Okay, so I figure I'll tell a little story about this, which is, we just celebrated the 20th anniversary of the Human Genome Project. And as Holden mentioned, I deal with the physical sciences. And so 20 years ago, I was in graduate school studying chemistry at Berkeley. And, they had that big ceremony. Bill Clinton invited them to the White House, and it, was on the front page of the paper. And, I was in the lab doing my thing, and my dad called me up in the lab. And, my dad, he's a musician, and he called me up and he said, "Why aren't you doing this? This is what's exciting. What do you do? Why aren't you doing DNA?" And so I tell that story because one of the things that happens, unfortunately, is that science can be a little siloed. And if you're, for instance, a biologist, maybe you only really find out what's exciting in chemistry if you read about it on the front page of the newspaper, which happens maybe once every 5 years, right? And so the point of Science Magazine is to facilitate conversations between disciplines a little more frequently than that. And so the idea behind what we do is that we consult people in multiple different fields, and we say to them, look, you have an opportunity now to put a chemistry paper in front of a whole bunch of biologists, astronomers, geologists, ecologists, and so forth, right? Which chemistry paper do you think we should put out there for those folks to look at and say, oh, this is what's really cool in chemistry right now. This is what the chemists are excited about. And this is what maybe, if I want to collaborate with a chemist, this is the kind of thing that I should be thinking about. And so the way that we do that is twofold. One is that we try to talk to a lot of chemists all over the world and say, hey, if you have something exciting, send us a paper. And then the second thing is that we try to have a multifaceted and diverse reviewer pool, so that then we're consulting the people in that field, and we're saying, I'm going to use chemist a lot because that's my background. But of course, this pertains to all the fields we cover. I don't really handle astronomy papers. I just supervise a very talented astronomy editor who does that himself. And so basically, the idea is that we are trying, ideally in a bottom-up way, to get papers from each discipline that particular discipline thinks are really exciting, and that their sort of cream of the crop that they think should be shared with other people. And the one thing that I try to make very, very clear when I talk about this is that I have no illusion that I'm publishing all of the good papers. There are far, far more outstanding papers than Science Magazine can accommodate. Because part of our mission is that we want people to look at it every week. And so, if you are an immunologist, you're not going to go read Journal of the American Chemical Society and see 50 chemistry papers, right? You're maybe going to have the appetite or the time to read 2 chemistry papers a week. And so, that particular week, there's inevitably going to be more than 2 really good chemistry papers coming out somewhere. And so I don't represent myself as saying, well, all the chemistry you have to read is going to be published in Science, right? That's not the goal. The goal is to get some small fraction of what's really good so that field is putting on its best face in front of all the other fields.
Right.
Well, yeah, and I think one thing of that story that I always add when I give these talks, just to help people keep things in perspective, is you can be the editor-in-chief of Science even if you never got a paper into Science, because I never did. But I got a lot of, as Jake said, I was fortunate and got a lot of papers in the ACS journals. And so, there's a lot of really good disciplinary journals that, you can make your career in.
Right.
And so we're looking for things that, will appeal broadly across a lot of disciplines, in addition to being outstanding papers.
That makes a lot of sense. And it reminds me of something we were talking about before we kicked off here. Maybe you could just unpack that a little bit more. So it sounds like maybe the biggest mission of the journal then is to take the best of every field and make sure you get it in front of scientists who aren't in that field. Is it in part to allow real interdisciplinary work to happen so that people are actually seeing potential intersections and synergies?
Absolutely.
Okay.
I think that is our number one goal. Absolutely. That's what we really want to try to do, is we want to facilitate collaborations in ways that people might not even have foreseen before they see that paper. And so it gets them thinking, it maybe gets them in contact with each other, and it really, helps those sorts of projects take off. And ideally, then, we publish some of that follow-up work to showcase, how that collaboration has gone.
Yeah, and I think the other thing is that that Science is not just a journal. There's the research papers, there's reviews. So there aren't many journals that have both research papers and reviews. And then there's what we call insights, which are our commentary pieces and news. So you're situating these papers in a publication. I mean, most people don't get the print journal anymore. There are still a few who do, and we appreciate it because it's beautiful and we enjoy making it. But you're taking research papers and you're putting them in this matrix that has commentary and thoughts about all of science, very broadly defined. And, we're fortunate. It's really just us and Nature that get to do that, to have news and commentary and research. But that's part of, it's all one piece of cloth when you think about, producing things that lots of other scientists would want to see.
Absolutely.
And I think, sorry, just to jump in really quick, I think another sort of benefit of what Holden is saying is that we're not only communicating with scientists. There are people in policy, who have influential positions in government, who hopefully will be taking a look at as Holden said, some of our really outstanding commentary. And then while they're in the process of looking at that, they might also take a look at some of the high profile research, and then that might influence, how they understand where the research enterprise is headed.
Those are both such important points. So to, bring this back to the student who I know is listening right now, hopefully the many students who are listening. So if you were even going to decide to try, okay, and submit something to science, what are the questions you should be asking yourself? Should you be asking yourself, is this really that earth-shattering in my field? Is this big enough? I'll ask you questions about maybe how to go about writing that later, because I think there are probably tips that you have on that front as well. But just in terms of, how you'd go about thinking about whether this is something that would be a good fit or not. What type of cognitive process would you tell me to tell my students?
Well, I mean, I think the most important thing is don't talk yourself out of it, right? I mean, the worst thing that happens is you send it in and we turn it away and then you send it somewhere else, right?
But,
so don't think of it as that daunting, right? I'm not an especially scary person, right? I mean, I'm just gonna send you an email and the email is gonna say, send it to one of the other outstanding journals that are available in your field,
Mm-hmm.
right? So, I always wanna, there isn't, even though we do turn away a lot of papers, we don't do it with malice.
Right.
We really want to try to encourage people and to make sure they understand that even if one paper doesn't make it, that's not to say that another paper won't. I think as Holden was saying, that the real key is that we want this paper to be accessible and appealing to people outside the field. Now, that doesn't mean that the paper itself must be interdisciplinary. But what it does mean is that it needs to be a discrete enough advance that it distinguishes itself from the many similar papers in your field's journal.
Right. That makes
Right.
sense.
Because otherwise, somebody will look at it and they'll say, well, why was this in Science when, 2 or 3 quite similar papers appeared in my field's disciplinary journal? And so I think that that's sort of, the way that you're thinking about it as a student, you're reading papers day in, day out. And if you get a result where you think, this is a cut above, this pushes the field in a direction a little more, whether it's a little broader or a little deeper, a little more than what I'm used to reading in my field's general journal.
That's really good advice. So, and the next question is kind of a perfect follow-up to this, because what actually happens with the review process? So it sounds to me, based on what Holden said earlier, is that you do send it to scientists outside of the specific field, right, as well. So who does the initial, if you just sort of walk, Jake, I think this is a question for you, but if you could just sort of walk me through the process, like you get a paper.
Yeah, absolutely. What happens is I wake up in the morning and run around with my kids and then, eventually we all quiet down and I turn on my computer and there's usually on the order of about 30 papers that have come in the physical sciences each day.
Wow.
And so the first thing that I do is I figure out who's going to handle each of those papers as an editor. And usually that's pretty easy, right? I give the optics papers to the optics person, the astronomy papers to the astronomer, and so forth. But sometimes, there are papers where it's kind of tricky to figure it out, right? If it's even within the physical sciences, if it's a paper about, let's say it's applied physics, am I going to give it to the material science editor because it's really about manufacturing the device? Or am I going to give it to the physics editor because it's really more about the performance of the device? Mm-hmm. And so that's a little nuanced. But once we've done that, then, one of those 10 editors will have a preliminary look at the paper and send it to a member of our advisory board. Or sometimes another member, sometimes maybe, between 1 and 3 advisors, usually just one, but, if it's interdisciplinary, then you're going to want multiple points of view. And these are practicing scientists who have volunteered to look at between 3 and 5 papers a week for us. And what they're doing is not doing a technical review. They're just saying, when I read this over, is this really exciting? Is this kind of what, as I was saying previously, is this a paper that's a cut above what I usually see in my field's top journal?
So is this the triage stage?
Yeah, right.
Just for everybody
Exactly.
who wonders what that is, if you've ever submitted
Exactly.
something to science, usually you get a no back very quickly, which at least
So-
that's nice.
Right. So ideally, that's a process that's going to take about a week. And you know, once that advisor returns comments, then we at least 2 editors have a discussion about it. Obviously, all you know, even prior to everybody working from home, this was generally a virtual discussion because we have editors in Cambridge, England, and editors in Washington, D.C., and so forth. And so we have a database where we send notes to each other about, you know, what we think of the paper and what we think of the advisor's comments. And then we decide collectively, are we going to send it out for deeper technical review, or are we, as you said, you know, going to send it back to the authors? And I want to say a word about our advisory board, because I think that, you know, especially a journal that has a long, prestigious history has a danger of falling into a sort of, you know, old boy network on the advisory board. And we've worked very hard, especially since Holden has joined the staff, to try to make sure that doesn't happen, and to really try to diversify our board in all respects, in terms of gender, in terms of racial and ethnic background, in terms of geography, in terms of age. You know, we don't want sort of, you know, 10 old men telling us which paper to take. So we try to really make sure that the advice we're getting is from people who represent the future of the field and not just the past.
That is spectacular to hear. I have to tell you that, you know, actually wasn't even on my list, but really should have been. And I'm very happy to hear you say that. I think that probably comes as a relief to more than just me.
Yeah, we still have a long way to go, but we've made a lot of progress the last year, as Jake said, and that's really due in part to Jake and his colleagues having the connections that we needed to get more people involved. But one thing I do want to point out, we have a page on our website that has the statistics about how many papers get we call it
Triaged.
Yeah, triaged. We call it. Yeah. How many get triaged? How many get reviewed? How many get published for all 6 of our journals, and how long it takes? And that's easily found from the right rail. We call it the right-hand side of our website.
Okay, that's helpful.
Yeah.
So I'm trying to get back to these tips, you know, and I get it. I think that must be very difficult to give people tips beyond send us stuff that you think is really revolutionary or just really, really new that's going to move the field forward.
Well, I think that, you know, one of the most important things, right? And I mean, this is awkward because, you know, unfortunately, science is exceptionally competitive, right? I'm aware of that. You know, I don't sort of have a, you know,
really,
if anything, I have to try very hard not to be cynical, right?
Yeah.
But I think that in an ideal world, you know, one way to gauge if your paper is you know gonna succeed at science is to try to talk to somebody who is not exactly, you know, right centrally in your discipline, and, you know, someone who you maybe have a professional relationship with who is just, you know, a little bit to the side of what you do.
Yeah, that's a great.
And to say to that person, hey, you know, does this excite you? You know, if I give you this pitch, you know, do you kind of have a sense of why this is a big deal, or are you sort of thinking, well, yeah, I mean, I could see that in you know, in our standard journal, and I would probably turn the page and go to the paper that's about my thing. Or would they say, ooh, yeah, you know, I see why the folks doing what you do have really been waiting a long time for this. So, and the other thing I would say that's really important is, you know, write the paper straight. Don't try to introduce a bunch of pretensions about, you know, why it's more important in some unrelated way to what excites you personally.
Yeah, I hope my students are listening.
Yeah, I mean, really, the best way to write a paper is to explain why you got excited about the result.
Mm-hmm.
And then once you've done that, then the second most important thing to do is to give proper credit to the people whose work you built on.
Absolutely.
Because, one of the things that reviewers really dislike the most is when you sum up their work by just, citing 10 references in a little block and then moving on to what you did, right? So, that I would say the most important thing not to do when you're introducing your work for a science paper is to say, people have been doing this for a while, reference 1 through 10, here's what we did, right? You really want to, especially when you think about the fact that I'm going to send it to one of the authors of those 10 references, you want to try to make that person feel a little good about what they did before, right? You want to say, well, part of the reason why I was able to do this is because so-and-so laid the groundwork so well.
Okay.
And then that's going to get that person on your side, right? Think about if you were that person and
Absolutely.
I sent you a paper to review and you said, look at that. Look at the way they took the ball from me and ran it down the field, to use an analogy I think people at Notre Dame might appreciate, so
yes.
That's that I think is, just going a little bit out of your way to, to be friendly in how you acknowledge people's prior work. I think will ingratiate you to them when we ask them to assess your paper.
I think
Yeah,
that's excellent.
and I think one thing to remember too is that Jake and his colleagues, as you just heard, he looks at 30 papers every morning.
Man,
These folks read papers for a living. So you can't get cute, right?
Right.
I mean, because
Right.
you're showing these papers
you've
to
seen it
people
all.
who read papers for a living. Okay. So, as Jake said, tell it straight, because there isn't any flourish that's going to be the magical thing. And so explaining what you did and why you did it as clearly and succinctly as you can saves everybody time and will get you the most honest reading of what you're doing.
And tell me if I'm reading into this, but it sounds to me like what you're really both saying is that, there are these few writing tips, but really it's about the science, it's about the work.
Yeah.
And then of course you want to write it well, but the science itself is going to drive these decisions more than any fancy writing tips might suggest.
Right. Absolutely.
Okay.
Yeah. And a science paper compared to papers that I wrote when I was sending my papers to ACS journals when I was a faculty member, a science paper gets a lot more editing than a paper in JAX or one of the other ACS journals, where you have a very busy academic editor who's handling it, who picks the reviewers and doesn't look at it again until it comes back, and then sends your revised manuscript to somebody who's good at getting all the semicolons and the references straight and all that stuff. But a science paper, Jake and his colleagues are professionals at revising them so that they fit and tell the story in an engaging way. And so, there's no reason to worry in a crazy way about that. We're going to get all that straightened out.
Right.
That's a nice benefit, because you're right. That's not true of very many journals, although that's probably why they all read so nicely. So the next question is almost the flip side of that. And maybe you can even get a little more specific, Jake, about what not to do. But that's the idea, is like on a practical level, is there anything you should avoid that's going to turn you or one of the reviewers off just, instantaneously?
As I said, the most important thing is don't understate and underrate important precedents. You're basically, your goal is not to fool me into taking the paper, right? If what you want to say is that your result is a big step beyond the most obvious prior precedent, then make that case, right? And don't make it in a, what's the word? Don't make it in a
Flippant way almost.
Yeah, I mean, don't try to build the prior work up instead of shooting it down.
Yeah.
Instead of saying, and I should clarify that very few people really live up to what I'm saying right now. scientists have developed an extraordinary vocabulary of euphemistic ways of saying that the prior work was lousy. And I think that's unfortunate, because I think that a better way to do it, as I said, is to say that the prior work really inspired you to focus on, where it could be improved. Which is a very different way of saying, this remains an unsolved problem because, these folks who did it before didn't get it right.
Didn't know what they were talking about.
Right? Because then what you've set yourself up for is the reviewer saying, well, you haven't actually solved the problem either.
Yeah. Exactly.
And so, trying to say, look, here's a puzzle and they put these pieces in and we're putting these pieces in. And maybe we're not completely done with the puzzle now, but we're seeing the whole picture of the puzzle a lot better than we were before.
It's just so valuable to hear you saying this, because I do, I don't think this is science's temperament necessarily, but I do think somehow we get trained that everything has to be so novel and sexy and new, and that we need to sell. And then there's also the tradition, I think, at journal clubs, where really you read papers and all you do is tear them down, right? It's just this deconstructive process. And, once you've sufficiently ripped it to shreds, then you feel somehow, intellectually satisfied. And I always think that's just half of it. So it's not only acknowledging what came before you and honoring that, but also building things back up. So it's nice to hear you say, write it simply, don't use a ton of jargon, and credit the people who came before you. And it sounds like those are two of the biggest tips.
The other thing I would say, and this is especially true now, there's been, I would say, a real revolution in attitudes about data archiving and data access in the past 5 to 10 years. And I think more than ever, it's really important to show your data and to make your analysis transparent.
Absolutely.
So explain how you did your statistics, show, the data underlying your statistics if you want to deposit it so that people can, maybe so that rather than saying, oh, it's on my grad student's computer, and if you send me an email, then I'll send my grad student an email and then she'll get around to it at some point, when she's done doing the other, right? So, think about, and especially if you're a graduate student writing your paper, think about how you would feel if somebody else's graduate student halfway around the world wrote to you and said, please drop what you're doing and send me an inventory of, what, right? So package your data so that people can get to it in a way that doesn't bother you later.
Okay.
And I think that also is that's a real sea change, right? That's not conventional because, when I was in graduate school, I was, I already told you this was, I dated myself. It was around the turn of the millennium, right? I was kind of the last paper generation. When I submitted my papers, I put printouts in a box and I, closed the box and took it down to the mailroom and they mailed it off to the journal, and that journal, I guess, I don't know, they probably threw it out by now, but in theory they have it on microfiche or whatnot, right? But nowadays it's all files, right? It's all files on a computer. And so it's just a question of, what is your file archiving strategy? And I guarantee you your funder is thinking about this.
Oh, sure.
Because I spend half of my time listening to funders tell me that I need to do a better job of pushing authors to archive their data.
Okay, right? Very important. I'm glad to hear that too. I think making data available is essential so people can actually, look a little bit more closely at the results. So this next question, it can be quick, but it's kind of personal for me too, because I've gotten stuck at the revise, resubmit stage, which is so disappointing. I wonder if you have the data for if you do get reviewed. There are all these rumors about how much do your chances go up. I mean, getting past the triage stage. But the question really is, is there anything that you should do or should not do at that revise and resubmit stage that might help? Are there any general rules for what you're going to be looking for in the subsequent submission? Other, I guess, than just making sure that they've done everything that the reviewers have asked.
I would say certainly if we're offering you a revision, we take the vast majority of those papers, right? I mean, we reject some, I would say we reject probably between a third and half of papers that we review.
Okay.
Whereas we only review about, 20, 25%, right? So about 3/4 of the papers we're not reviewing, but the papers that we do review, there's a pretty good chance.
Yeah, so I really messed up.
I think that the really important thing that I would say, and this is especially true at Science because, you have one of the really nice things that we do at Science Magazine is that you have an editor who is gonna know who you are, and you have my email address. And so, you should write me an email, right? If you're saying, well, look, one reviewer said, walk east, and the other reviewer said walk west. And so do you want me to stay still, or what do you want me to do? And ideally, I'll have explained to you in my own, revision email what I want you to do. But if you don't know, I am very open to iterating with authors, because I would much rather that you ask me ahead of time than that you went away for a month and then came back and sent me something, and it turns out that, it's in the opposite direction of what I thought would really satisfy the reviewer. So have a conversation, don't be shy about writing to the editor. We also, if you really think that, one of the reviewers just didn't get it, it's also helpful to tell me that first, because I will absorb your frustration, right? So if the first thing that you want to do is just write 50 sentences about how mad that reviewer made you, and how, this is somebody who just doesn't even understand the first thing about this field, and what you're asking for is ridiculous, and I've been working in this field for 30 years and I've never had somebody send me comments that are so ridiculous, send that email to me.
Right.
And then you've gotten it off your chest, and then once you're actually writing something that reviewer is going to see again, you can write it in a slightly more professional way, because again, I'm not looking to I'm not looking to watch battles for their own sake. I'm looking to resolve conflict and get people to a mutually agreeable outcome.
I'm sad that none of our papers will come to you. I think that everybody should capitalize on having an editor like Jake, who's you're very generous if you'll let people rant at you. I would say rant in your rant first, then tone it down, then send it to Jake. But because I'm mindful of time, I'm going to skip ahead here just a little bit.
Sure.
But Holden, I wanted to ask you about working with students and hopefully teaching them, equipping them in some way to meet with publishing success. So, in my lab, I'm very lucky. I have 2 wonderful postdocs. I've got 5 stellar grad students, and at any time we have between 20 and 25 undergrads in the lab. I guess, how do I help them prepare to be successful as authors of papers? Or in your experience, what can we really do as faculty, as PIs, to help our students learn to think and write about their work in a way that gives them the best chance at publishing it?
Yeah, there's no shortcut around sitting them in front of the screen and making them stare at the blank abyss that comes when you push Control N in Microsoft Word.
Right.
Like that's I write a column every week, sometimes 2, because I have a blog and sometimes I have an editorial. So I have to do this 2 times a week. And it's, I've been doing it my whole life, and it can still be intimidating when I don't know what to do. So, we have to push the students through that process. And then, going back and forth with them. I learned it from one of the most prolific scientific educators in the world, Harry Gray, who put more than 100 students into academia. I sent him terrible. It was back in the days when we printed everything out. Jake was kidding about being in graduate school during the millennium. I was in graduate school when Alf was on TV. So I used to print out my papers, and Harry used to take them on a trip with him and destroy them and give me this manuscript that was covered in, he had very neat handwriting, which I didn't have. It doesn't matter as much anymore, but back in those days, because he could rewrite the whole paper in between the lines if it was double spaced. And I learned so much from that. So I think that the hard work of for the advisors and the students, it's easier. There were times when I was first starting out where I just sat down and typed out the paper because I was young and hungry and wanted to get my first Jack's paper or whatever it was. But that's not a good educational decision. The right thing is to get the students to write the papers and to go back and forth. And my postdoc advisor, we read the papers out loud all the way through before we submitted them, which was not something I was used to, but I learned a lot from that too. Not so much for me because Harry had taught me a lot, but for working with my own students. So there's no shortcut around this. I think another thing that can be really good is to get students involved in writing, review and commentary kinds of content, just so they get used to the scientific style. And then I think for reviewing, certainly seeing the reviews on their own papers, and then when they're postdocs, I think, letting them participate in the reviewing of the papers is something we actually encourage.
Those are all such great tips. They really are. And I think that maybe there's just no shortcut for doing it, and doing it and doing it and doing it. And even if you're a good writer to begin with, scientific writing really is different. So, just a couple more questions. I can see that we actually do have quite a few questions coming in from the audience. So let me just get through one or two more here in the last few minutes we have devoted to this piece. But I think this is important. So I don't just think, I know, and I think we'd all agree that worthwhile science clearly isn't just the research that makes it, into the journal or onto the journal's cover or its homepage or even onto somebody's, social media or Twitter account or whatever. And yet, there's this tension, I guess, because anyone who's ever been through the tenure review process, knows firsthand that it's real. This publish or perish environment is real. And, I just would like to get your thoughts about that, because I find myself in the following conversations with my students all the time, and I'm always uncomfortable. So on the one hand, I'm saying, this is the way it is. You need to publish a lot. There's a quantity, issue, but there's also a quality issue. So it's like, go fast, but slow down. And then at the same time, it's, I really want you to, sort of prioritize research and publishing and getting things done fairly quickly. But at the same time, I know that we have this replication crisis in psychology, especially in social psychology. And I'd not say that this like drive that we all feel to publish is the only cause of that, but I do think it might be one where there's so much pressure to publish that we're not doing the slow, methodical, careful, replicative, well-powered work that we know we should be doing as methodologists. And I'm being honest, I find myself sometimes tripping over my tongue because I feel like I'm giving them mixed messages. And so I'm just wondering if you could speak to that a little bit, how you think about it. Yeah.
So it's one of these problems that people are good at describing and not doing anything about. It's unavoidable that review committees look at the number of publications and where they're published. And, if you're in the publishing realm like Jake and me, we go to many, many meetings at the National Academies or this society or that society where people talk about this problem. But I guarantee you, if my own kid becomes a professor and asks me what he's supposed to do to get tenure, I'm going to tell him, go ask his colleagues how many and papers he needs to publish and in which journals.
Yeah.
Because I don't think that's going to change anytime soon. I do think there are some things we can do around all this, and one is try to get back to people quickly about their papers. That's why, as Jake said, if we get back to you in a week that we're not going to publish your paper, then you can move on. And people don't like getting that news, but I like it that we don't drag everybody through 6 months of review before we decide whether to take the paper. And then I think the other thing is, to the extent that we can as leaders, it's like, that's why I always start off these talks by saying, I never got a paper into science, but I'm the editor-in-chief. Because, you know, it does change your life to get a paper in science. And I hope everybody watching gets to have that experience. But it doesn't mean you're not going to have a great life as a scholar if you don't do it. Because Psychological Science is a fine journal. And so are J Neuro and a lot of other journals in your field, which I wouldn't know that. Only know the names of because my son is in your field.
Yeah, so, and I feel like, you know, you're picking the ones I've actually managed to publish in.
Okay,
so thank you for that. So one last question, and then I'm going to jump to the audience questions, if that's okay, since I think we've only got about 15 minutes left. But, you know, I guess the last question I have is really, again, Holden touches on something that came up in the last interview, the last session, which is about, you know, sort of the public's kind of atrocious science education level, and, you know, what that really means for society and how important it is to, you know, get our science out there to the public, get them understanding it, helping them understand why it's so important. And, you know, I'm just wondering what you think the role of journals like yours are in that, you know, and if there are any, you know, how do you determine sort of what you push out on social media? Because that obviously helps reach, you know, a broader audience than just reading the journals. So what do you think about our responsibilities as scientists and yours as publishers and editors? And I guess, are there any other creative ideas about how we can help people understand just how important science is?
I think that there are really two separate questions there. And I think they get conflated in a way that makes it hard to answer this question.
Okay.
So there is a good faith version of this. And the good faith version is, you know, there is a pressing interface between science and public policy that people really need to understand, and they're confused about it. And a good example of that is, you know, how masks work when you're trying not to get COVID. And we published a really outstanding commentary article that got a tremendous amount of worthwhile attention, that had just a beautiful infographic about, you know, what these masks are doing, and, you know, how the various kinds of masks helps you. What happens if, you know, only you're wearing a mask, or, you know, you're talking to somebody and you're both wearing masks, and so forth. And, you know, really just delved into, in a short and succinct, but still scientifically rigorous way, you know, this is why you should be doing this. It's published in an authoritative source written by people whose opinions have been carefully vetted. And, you know, you can rely on this, right? So that, I think, we do a good job with. I think it was fantastic that we published that piece. And I think that's what we should be doing. But there is a second problem, which is a situation where you're combating deliberate bad faith misinformation, right? You know, where you have people who are deliberately trying to sow doubt, for instance, about the climate change consensus. And that's a much harder issue, right? Because our goal really then is not to educate people on a neutral baseline. You know, then what we're really being asked to do is to sort of, you know, combat a misinformation campaign. And or disinformation. I don't know if it's misinformation, disinformation, or you know, but
there's been quite a bit of both.
but the point is that that's much harder for us to do because it's a different problem. And the issue is that if you're combating someone who's arguing in bad faith, then you end up getting, wrapped up in that bad faith argument.
Totally.
And then they say, well, okay, science is not a neutral arbiter on this question.
Yes.
And then, there's a real question of, who exactly are we communicating with? Are we communicating with the public, or are we just, having a snowball fight?
That's such a good point.
And so personally, when I think about my job, I have a much easier time thinking about the first category than the second category. I think dealing with, combating deliberate misinformation is a very thorny problem. And I'm not exactly sure what the best way is to do it. I think, psychologists have a tremendous amount to contribute in answering that question.
I love that. Kick it back to us.
Yeah, I mean, just to add to that, I think, Jake summarized it well, but we view our first job as producing something that other scientists want to look at and read and be informed by. And yeah, we have a lot of reach, a lot more than other journals. We have 2 million followers on our Twitter account and 5 million on Facebook. So that seems really big to us, but it is small compared to a lot of the forces that we are competing against.
It's very,
And so, thankfully, my boss, Sudip Parikh, when he came in as the CEO of AAAS, one of the first things he did was help us nail down the fact that science's audience is other scientists. If, as Jake said, we had that mask perspective that got viewed millions of times. I've had a couple of editorials that escaped the gravitational pull of the earth. It was not an experience I want to have every week because it took a lot of my time. Okay. But I don't sit down at the computer and try to write a piece that's going to get reprinted in the New York Times. I'm sitting down to write, what do other scientists want to know about what's going on right now? And that's our primary job. And the secondary job of convincing people that science is real and that we know what we're doing and that this is a process, not just facts that fall out of the sky, is a very, very hard job. And the people, and most of us who spend our careers writing jargon are not equipped to do it.
Absolutely. I couldn't agree with that more. So I want to at least get to a few of the questions. We actually have a lot coming in, and I know we didn't have a chance to get to them last time. So how about we start with this one? This is from Aaron, who's an external guest, asking, can you talk about the pre-submission inquiry process and whether you recommend it?
It's a complicated question. I never want to dissuade somebody from writing to me. I want to be unintimidating. I want somebody to feel like I'm an ordinary human being who they can communicate with. And I especially appreciate a thoughtful pre-submission inquiry that says something like, this is an interdisciplinary paper and we're wondering if we've conveyed it in such a way that the people on one side are going to understand what we're saying about the other side. Or if they're going to write to me and they're going to say, in a thoughtful way, we're wondering if you think this is a big enough advance for us to send to you because, caveat, this is what we're kind of vacillating about, right? And I take the time to write back. Well, I always take the time to write back, but those are the kinds of emails that I will write a long response to. The kind of email where somebody sends me a paper that's attached and they say, dear Dr. Yeston, will you review this paper if I submit it to Science? Right? Then they're short-circuiting the process,
yes.
Right? Because the process is that we have an advisory board and I have colleagues and so on, right? So that is not a productive use of my time. If what you're asking is, will you run this through your process? The answer is, of course, I'll run it through my process because that's what we do. Send it through the website, take an extra 10 minutes, and we'll let you know in a week, right? And so what I would say is, if you are asking, and you should always feel free to ask, please try to ask the question in a way that conveys why you might have doubts about it, or what in your paper you think it would be helpful for me to help you clarify. Don't just send me an email that says, I'm doing one extra thing to make you feel guilty about not rejecting it.
Yeah.
Right. That's the real point, right? I've now put my name in your head. I've now put my name in your head so that when it comes in over the website, you'll think, oh, this person sent me an email, right?
Right.
That's not really a substantive discussion.
No, and I hope you don't get too much of that. All right. How about this for another question? This is from Marianne, actually, who's a Notre Dame faculty member. I would like the editors to discuss reproducibility in science and what the journals are doing to help in this area. And that does kind of touch on, my concerns about the replication crisis. So any thoughts about that, I think would be really helpful.
So, Holden's predecessor, Marsha Mcnutt, this was basically her number one priority. Excuse me. There was Jeremy Berg in between, but, that was prior to Jeremy. And this was, what she did at Science when she was the editor-in-chief, and then she went on to National Academy and has made it a priority there. And so she held a number of workshops about reproducibility in different fields. There was one in psychology, and there was one in molecular biology. There was one in material science. And the idea there was, getting a bunch of the stakeholders together and trying to figure out, what we can do to improve the situation. And that resulted in what are called the TOPS guidelines, the transparency and openness promotion. And those are stipulations like, for instance, you can't just say data available upon request. You have to actually put the data somewhere so that people can find it and they can reuse it. If you have software, we're going to ask you to deposit your software. If it's proprietary, we're going to ask you to describe it in sufficient detail that experts feel like they can legitimately vet it. Basically, and I think that people get a little irritable about this, right? Even if they don't anticipate that they're going to get irritable, it's a paradigm shift. It's a paradigm shift because people will start to say, well, I'm done with this paper and my grad student is on a new project right now. I don't want to answer your 50 nitpicky questions about how, you analyzed my data and you got something right. Yeah. And I think that's, that you can't really do that anymore. Now I don't want to say that I don't support harassing people, right? I think there's a line between, just being obnoxious and harassing people. And, I don't think that you should do it in bad faith. But I think that if you're going to publish a paper, especially if you're going to publish a paper in a high profile place like Science Magazine, you should expect that people are going to delve into it and they're going to come back to you and they're going to say, well, what about this? And, if your goal is to not answer those questions, then you shouldn't be publishing in Science Magazine. Right? Because we're trying to communicate, right? That's our goal. Our goal is to get your work into the hands of other people so that they can ask you those questions. Right. And if what you want to say is, I don't like putting my data out there because I don't want to take the time to respond to those questions, then I think that, there's just a disconnect between, how we're thinking about what publishing in a high profile journal really means.
Hear, hear. All right.
Yeah, so one other thing on that is just that, we're losing you, Jessica.
I know. I guess we did the light test. That I do have. Look, there is a light. It's just not very bright. Okay. Sorry about that. Right. It's okay. That's okay. Everybody should be focused on you two anyway.
All right. I don't like the phrase replication crisis because science is a honorably self-correcting process. We don't believe in phlogiston and polywater anymore. And, those were things that people published about and they were corrected, and there's nothing wrong with correcting a paper. Of course, we want to do everything we can on the front end to make sure we don't have to do it, but we make observations, we propose interpretations. And so as Jake is saying, I think there's a simple solution to this concept, which is people need to accept the fact that they got to put everything up there so that people can repeat what they did. And they got to be willing to engage when folks want to debate whether they have the right interpretation for their data. And so, you know, I like that. I don't like posting corrections and retractions and editorial expressions of concern, but if we weren't posting any, I would be worried.
That's true.
That we weren't doing enough adventurous stuff, or we weren't doing a good enough job of taking care of it after the fact.
Yeah, you know, that's the first time I thought about it that way, but that's a very important point. Well, listen, unfortunately, I want to apologize to the audience members who I didn't get to. This was an amazing conversation. It went so quickly, at least as far as I'm concerned. I want to kick it back to Marie Lynn. I know that you probably want to say a final thank you and goodbye.
Yeah. Well, thanks so much, Jess, and thanks so much to Jake and Holden. This has been the third and unfortunately for us, the final session of our State of Science discussions with editors from Science Magazine. I do it every Monday if I could get you guys together to do it. It's been a lot of fun. I think that we've all learned a lot from it. I want to remind the audience that the recordings of each of these three State of Science, the first one on the COVID-19 pandemic, the second one on interdisciplinarity, and of course today on how to get published in top journals, is going to be archived on that the Notre Dame Provost office website, same place that you came here for streaming, sorry. And you can feel free to point your grad students, postdocs, whoever, faculty colleagues, junior colleagues in your department who you're mentoring to any of those videos. I want to give a special thanks to Jake for joining us today. I know that you didn't quite know what we had in for you, what we had going for you, and you were just so great. Really, I loved your ability to talk the nitty gritty about good advice for do's and don'ts on how to submit a paper, but also to get people thinking about that, 50,000 foot. Is this really a paper that is this the paper that I want to send to Science as opposed to other things? And you've certainly established yourself as a friendly and welcoming face. I have a feeling that your inbox will be a little bit fuller from the people who have watched you this evening. Jess, I want to give a special thanks to you as well. You did a fantastic job with the interviewing. And of course, today is International Women's Day. So it's a science panel, and there are 2 women and 2 men. So we reached some balance, which seemed even more important on International Women's Day. And Holden, you are one of my favorite people to talk to about sports and about life and about science too. So thank you so much for being so generous with your time. I hope that we'll have many more opportunities in the future, and that post-pandemic we'll find ways to get together in person to discuss science some more, all kinds of different issues that face the world. So thanks, everyone. Good night.
Thank you so much.